Hello and welcome to meetup 74 for Python beginners. And today we're going to be looking at JSON, and we'll also be looking at regular expressions. So recently we had a meetup where we looked at the HTML and RSS and XML and how to get data from data sources. So today we're going to be looking at another form, which is JSON, and we'll look at the similar data sets from the Brisbane City Council. So this is a designed for beginners in Python. So feel free to ask questions. You can ask questions on YouTube chat, or you can ask questions on the Slack channel for beginners Python and the channel we're on is Learning to Code. So on that Learning to Code Learning to Code channel, I've put the URLs for the YouTube link and Colab workbook, which has been pre-populated with what we're going to be working on today. So it's also here on the meetup, and it's also on the YouTube. So the first thing to do, we're going to use Google Colab today, just the standard Google Colab. So it's free to use. You don't need to install Python. You don't need to install Python on your computer. I'm just going to adjust my sound up a bit, because it's a bit quiet apparently. Okay, we'll try with that. Okay, so by clicking on this link, it'll open up a new Google Colab notebook. And if you've got a Google account, you'll be able to save a copy in your account. So I've just opened a copy here, and if I go to Google Drive, the file menu, I'll say save a copy in Drive, and that'll save one in my area. And now I can start making changes to it. And I really encourage you to make changes as you're going, so that that's the best way to learn. This is a Jupyter notebook, so it's made up of a bunch of these cells. In the cells we can have text, like in this cell, or we can have Python code, like in this cell. And so to move down between the cells, you can just execute the cell. So you click in the cell, this is the Python code one, and you execute it. So to do that, you press Shift and Enter, or Shift and Return, or you can click on the play button there, and you can see it starts to run. And the very first one takes a bit of time to run, because it loads in all the Python stuff on Google Colab, but the rest should be fairly quick. And it'll print the number 1 in there to say that was the first one that you ran, and that it has been run. So what we're doing in this first cell, we're just making available some of the standard libraries that come with Python, so we can use them elsewhere. And I've done that using the import statement. So we're going to import the JSON library, the regular expression library. We're also going to use date, time, pretty print, HTML. And we're also going to use a couple of functions out of URL lib. Because we're only going to use 2 functions out of these ones, I've only imported those 2 functions. So you can see the import statement has a different look to it. So I say from the library, and in fact even the class within that library, import these functions URL open and URL retrieve. And it means that when we're going through the code, if ever I'm using something from the JSON library, I'll have to prefix it with a JSON and then a dot. And similarly with re dot, datetime dot. But when I'm using URL open and URL retrieve, they've been imported explicitly, so I don't need to prefix for them. Okay, so let's quickly have a look at some of the data that we're going to be using. We'll go to the Brisbane City Council website, and they've got a data page, an open data page, and they've got lots of data categories here. And this is public data that you can access programmatically and use it however you feel free. So we're going to look at events, and the one we're going to be looking at is the JSON data here. You can see it's coming. It also comes in RSS and XML, but we're going to be looking at it in the JSON format. So if I click into events, I can see the data here in these three formats. And if I click on download, that'll show me the actual data in the JSON format. And that's what it looks like. So this is JSON data. I'm just using Chrome here at the moment. So you can see it started off with a left square bracket, and then curly braces, and then double quotes and a string. It's pretty hard to see what this is, what the format of all of this is, but I'm in Chrome at the moment. So I've got Firefox running here somewhere, so I'll just bring that across and show you what it looks like in Firefox. So in Firefox, it's recognized it's JSON, and it gives us options. We can look at the headers, we can look at the raw data, we can look at the JSON itself. So the JSON, it's interpreted the JSON. So JSON is JavaScript object notation, and it's broken it all down. If we still want to look at the raw data at this stage, but we'll look at it in pretty print format. We'll turn on pretty print, and we can see that it's a left square bracket here, and that's in Python notation, that's the start of a list, and in JavaScript object notation, that's the start of an array. They're very, very similar. Then we've got the start of in curly braces, we've got the start of a mapping object. So in JavaScript, that's called a JavaScript object, and in Python, it's called a dictionary. And then you've got keys and values. So the event ID has this value, the template has this value, the title has this value. So this is the information that we're going to grab from the website, and we're going to download it into our program, and then we're going to use it. So to do that, we'll go back to Chrome and have a look at how to do that. Well, we've got, so first of all, let's do some exercises in converting between JSON and strings, just Python strings. And then we can work up to getting stuff over the network. So here's an example. We want the Python number, it's just an integer, 123, and we want to convert that into JSON. So we're going to use the dump s function, and dump s converts a value to a JSON formatted string. If you just use dump, it converts it into a JSON file. So we're going to use dump s to convert it to a string, and we're going to store it in a variable that I've called JSON_str. You can call it whatever you like, and then we'll print it out to see what it looks like. So if I run that cell, Shift Enter, you see I get 123 out. And the reason I get that is because a Python object notation and JavaScript object notation, they're very similar. And so 123 in Python actually is pretty much the same. In JSON, it's 123. Okay, and now I've printed that using the print statement. If we're using IPython here, so Jupyter Notebooks are IPython, and I can just do the variable name to have a look at what's in it. And just for comparison, I've put beside it a couple of values, 456 as an integer and 789 as a string. And we can see the 123, that's this JSON string, is stored in a string. But that string part, that's the S on dump S. The 123 is what the dump produces, but it puts it in a string so that we can then use it later. So looking at object notation, to Python to store an integer in a variable, we just type a equals 123. In JavaScript, you type a equals 123. and semicolon at the end, although I think even the new JavaScripts are getting rid of the semicolon. So these two languages are getting very, very close in how they work. Now, sometimes we want to convert back from a JSON string back into a Python object, and we can do that using load and load_s. So load_s converts the JSON formatted string back to Python, and load will convert it from a file back into a Python value. So if I run that one and we get 1, 2, 3, there's no quotes around it now. It's just the integer that gets returned, and I can use that in my Python code how I want to. So our first task is to convert a string to JSON and then convert it back to a Python string. All right, so let's start. We'll get a variable and we'll put in that a string. I'll just call it a string. And now we want to convert that into a JSON. So we would use the JSON library, and in there we want to use the dump s function, and we're going to dump s of s, and that's going to turn it into a JSON formatted string, and then we'll save that into our Python variable, which we'll call JS. Now we want to convert that back. We've done stuff with that. We've stored it. The great thing about strings is you can put them into a file, you can transfer them over a network, and then later on you can retrieve them and then convert them back. So we want to convert it back into a Python string, and so we'll say our Python string is equal to loading this string JS. All right, so and let's have a look at what we get when we get those back. So we started with S, we then went to JavaScript, and then we came back and we got Python string, our original Python value, whatever it is. And so there's the first S, that's a string. So when Python displays how it looks, we use double quotes in creating it, but it just, when it gives it back its representation of it, it used single quotes, so that's fine. Then JSON converts that into double quotes. So JSON likes to use double quotes, and then it's put it inside single quotes, which is our Python string. So that's the JSON, is double quotes space string, close double quotes, and then the JSON string is all of that inside that's stored in a Python string. So that's why you see those single quotes. And then when we convert it back to a Python string, we get exactly what we started with. So you can see JSON's been a reasonably good intermediate way of storing this data. We've converted it into JSON, and then we've converted it back. And we haven't lost any information. So that's the solution to task 1. Now I've put in a more comprehensive solution here, which does more than just a string, and it shows what would happen if you converted all the different data types into JSON and then converted them back, and just see where it works, where it doesn't work, and things to look out for. So I've got a list here of Python values. I iterate through that list using a for loop. I'm printing out the type of that, the data type of that value using type, and then I'm converting it into a JavaScript string, a JavaScript object notation, and putting that into a string. And then I'm comparing. There's our JSON representation. There's our original value, and I'm putting exclamation mark R here, which is the same as if I typed REPR of our original Python value. And then I'm converting it back to a Python value from the JavaScript object notation string, and also using !R to compare. So let's run that and see what it looks like for all the different data types. So when we get an int, 234 gets converted to 234. So there's our original value. It gets converted to 234 and then gets converted back. So we can compare these two. They look identical, so that's good. Similarly, a float, 345.6 gets converted to the same thing and then back. So it's all looking very good. Now we could try a complex number. So in Python, 3 plus 4j can't be converted to JSON. So we're getting a type error. And I've put this code here in a try so I can catch that error. So it does that, except if there's an error, type error, and then it just says print the original value and say that it can't be converted. So we know that complex numbers can't be converted to JSON. It's not JSON serializable. So this is my error message, and this is the error message that came from type error. Okay, strings. We started with my string. It's showing that it was single quotes. JSON's got it there with double quotes. Gets converted back to single quotes, just like I did in my solution. We have a list. The list looks pretty good. The only difference between JSON and Python object notation is the JSON has got double quotes around the strings and Python's using single quotes, even though Python could use double quotes. So that's a list. A tuple. So a tuple here, you can see it's represented, it's got the parentheses surrounding the values. Inside the values, I've even put in some floating point numbers in exponential notation. It gets converted to a JSON, which uses square brackets. Now, when that gets converted back, it gets converted back as a list. And that's because JSON doesn't distinguish between tuples and lists. And really, the only difference between them is one's read-only and the other one is mutable. So in terms of a serializable format, a format for saving in files or transferring across the network, it doesn't matter whether it's mutable or immutable. So it's understandable that JSON doesn't distinguish between those two. All right, here's the dictionary. So see if you can see what the difference is here between the original value and the converted value. They look pretty similar when you go from the original value to the JSON, except that when you use a numeric key in Python, it doesn't need to have, it can use a number, while in JSON it has to be a string. So in JSON, it puts the quotes around it, which means that when it gets reconverted back, it will now have quotes around it. So our numeric key has now become a string key. Booleans, they not much difference. In Python, true has got a capital T, JavaScript's got a lowercase t, and that converts back properly. For none, Python uses none, JavaScript uses null. It gets converted back to none. All right, then we tried using a set. So a set was here as an example, string and a set and a number, but it can't be converted to JSON because JSON doesn't have a concept of set. So don't try doing sets. And similarly, date time, I've used a date time object here, but it can't be converted to JSON. So JSON, you've seen now all the data types that JSON can do. It can do nulls, booleans, dictionary types, which they're called objects. It can do lists, strings, floating point, and integers. All right, so let's test here whether JSON works with single and double quotes. So say our JSON string had double quotes in it, which is like this one, and we convert that, and then say the JSON string was using single quotes and try to decode that. So we'll run that, and the results were JSON can store strings in double quotes, but it can't store strings in single quotes, and that's the error message that it gave. So you might be asking, why if we're using Python would we be trying to use JavaScript object notation? And there is a way we can do it in Python itself. So we can use the REPR, which is a way of converting any Python value into a string. And then we can use EVAL, and that'll convert any Python string back into a value. So let's have a look at what we get when we do that. So I've taken the complex number 3 plus 4j, and that gets converted into a string, which is parentheses 3 plus 4j, close parentheses. So that's a complex number, and that works really well with REPR. And we can then use eval on that and convert it back. As you can see, it comes back to 3 plus 4j, and the type of the conversion back is complex numbers. So that seems great. Why bother with JSON when we can use these strings here? And the reason we do it is because it's a security risk. The eval can evaluate any Python expression. So like it could evaluate this, c times c, and give us the answer minus 7 plus 24j. So if someone had access to that data, that they could start putting Python expressions into that data and maybe print out passwords or something else that's stored in your code somewhere. And that would be a security risk. So you can see here, this is the complex number, which is the result of 3 plus 4j times 3 plus 4j. Okay, so feel free to ask me any questions. What I might do is I'll share this notebook here, which has got the answers that I've been typing in, and I'll try to put it onto the YouTube chat, but I think they might, YouTube chat doesn't like me typing URLs. So I can see it on my YouTube chat, but if you guys want to check to see if it's turning up on your YouTube chat, but I'll also put it in the Slack channel. It's on the Slack channel, and I'll also just see if I can do the last part of it. I'll put this into the YouTube chat as well. Okay, so this is a different link. This is the link that was on the YouTube page, and that link is the original file. And this link here is now going to have any extra answers that I've typed in, and you can refresh that during the course of the video and see, and then you'll get copies of anything that I've typed into this Jupyter notebook. All right, moving on. Okay, so we want to get this Brisbane City Council JSON data that we had a look at before. And so we're going to use URL open, which comes from the URL lib. We'll specify the URL is this value here. And we're going to load that straight into JSON and convert that into a Python variable called events. So if I run that now, that's going to take a couple of seconds. It was pretty quick. And it's loaded into events. So now if I look at what the type of events is and how many elements in events, and let's have a look at the first element. So the type of events is a list. There were 200 events in that list, and the first event is, now it's a Python dictionary, and it's got these keys and these values. So you can see here one category calendar, Brisbane's calendar, Museum of Brisbane. All right, alternatively, we can download the file. So we'll use URL retrieve, which is also from the URL lib. using the same URL. And if we look here, I'll just click on this folder here and we can see we've got no files in there. But if I run this URL retrieve, that downloads the file into Brisbane City Council .json and should eventually put it over here if everything worked well. So let's close and open that. There it is, Brisbane City Council.json. So we've now downloaded the file and saved it in our list of files over here, and now we can open that file, and anytime we want to use it now we can just open the file rather than going back to the Brisbane City Council site, or if we want to get refresh data then we would go back to the Brisbane City Council site. So let's, this is a good way of opening a file with open. This is just standard file opening things. We're going to call it JSON file. And then when we've got the JSON file, we can use json.load to load it into events. And it's done that pretty quickly. And we look at the first element in events and it's the same one. So that worked as well. Okay, so task 2, find the set of unique values for the key category calendar. So this is a beginner's Python video, so I'm going to type in a little Python program here. If you don't understand it, then definitely ask me questions, and then we'll see. We'll look at the solution. So we want to find a list of values. So let's create a list of categories. I'll just call it list category. We'll just make it an empty list. Now I want to loop through all the events, so I'm going to do a for loop. There we go. And we're going to get the category calendar is going to, we're going to access it from an event. Now event is a dictionary with key category calendar. And we just want unique values. So if the category is not in our list of categories, then we'll append it. No, that's not what I wanted. Okay. And then at the end, we'll print the categories, the list. All right. I don't want is. There we go. So here are the categories: Brisbane's Calendar, Museum of Brisbane, featured events in Brisbane, Brisbane's Calendar, active and healthy, active parks. And so you can see what we've done here. We've looped through all the events. We've checked to make sure we haven't already got it. And if we haven't already got it, we add it into the list and then we get the full list of them all. So this is one way of doing this code, but it turns out to be some of the things in this code are quite common requirements. Okay, someone's got a name error, URL retrieve is not defined. If you got URL retrieve not defined, then it means you didn't run this cell up here. So you can go back and run it now. So just click in it and shift enter, and it should run, and you should end up with a number in it. I had 1 in there before, now I've got 18 because it's the 18th cell that I've run. And that will define URL retrieve. So you should be able to then do the URL retrieve. I'm surprised you didn't get the same error on URL open though. Oh, okay, and that would also fix your name error, JSON is not defined, because that all of these, by doing these imports, all of those names get defined. So see how you go with that. close this. And these are good questions. Like it is a beginner session, so these are the sorts of questions. It's good that you ask these questions so that it helps everyone else who's having the same problems. So you can see every cell, you should get a number as you run it. But these ones here, I didn't run that one, and you see it hasn't got a number. It's just got a comment in it. The comments are defined by starting with a hash sign, and then anything after that is a comment. So I didn't bother running it, but I could have run it if I want, and just nothing would have happened. All right, so this was a common set of things that you would want to do. You'd want to loop through all the events. You'd want to check if something's unique and then store it in a list if you did. So they created a data type called set rather than list. And a set, you can just keep adding into a set and it would only do unique values. So for example, I could do it again using a set. So I define the set and then I do the same loop. And I don't need this command now because I'm using a set. And the difference here is I don't append to a set, you just add to a set. And I just keep adding it to the set. The set works out if it's unique. It puts it in, but it won't put it in more than once. And then we can print it out. Okay, and rather than print this time, prints it across the page, which is a bit difficult to read here. So I'm going to use prettyprint, and that's in a library that I've imported, so I have to use prettyprint.prettyprint. So let's try that. There we go. So the first line here is our list, because you see it's enclosed with square brackets. The second line is got curly braces, and that's a set. So curly braces without colons in it is a set. Curly braces when you've got key, colon, values, then that's a dictionary. Now in my solution here, I've done this in an even more compact form. I've used what's called set comprehension, and there's list comprehension, dictionary comprehension, and they're quick ways of creating sets or lists or dictionaries or tuples. So there's my loop for event in events. Then my category here is event category calendar, which is that bit there. And that gets put into a set. So I'm creating the set using the curly braces there. And because I've got no colon, it knows it's a set, not a dictionary. And then I'm doing even more. I'm sorting it, and that sorts them in order, in alphabetical order. And then I'm prettyprinting that. And I think sorted will give it as a list. So when I run that, there we go. There's all the results and sorted alphabetically. And actually, when I did a prettyprint on the set, it sorted it for me as well. So I didn't need to. I didn't actually need to do the sorted there. All right, so the one we're going to be looking at mostly here is this Planetarium one. So that's going to be the topic of our next tasks. Oh, first of all, we're going to do this. We can convert dates and times. So let's have a look at our data. So end date time here is, you can see it's a string, and it's year dash month dash day with a capital T and then hour, minute, seconds. So we prefer to have this, it's a string, we can do a little bit with it, but we can't do any date calculations on it really without converting it into a proper date time object. So datetime's handled in the datetime library, and we've got a function here called string parseTime, and that'll parse the time based on format. So I'll copy, sorry for all this scrolling up and down, but I'll copy a value. So let's try this one. Well, in fact, I'll just grab it, end date time in the event 0. So events 0 is a dictionary, and in that dictionary we're looking at the end date time, and that's our string. Now we want to parse that into a date time value. So let's see, we say dt equals, so I'm going to call from the datetime library, so I have to prefix it with datetime dot because that's how I imported it. And in there is a class called datetime, confusingly, and in there is a function that I want to use called string parseTime. You can see this command completion is helping for me. So I'm going to, it takes a string and a format and returns the date time. So I give it the string that I want to parse, and then I give it a format, and the format is another string, and I just use these codes that I've listed here. So I want a 4-digit year, %Y, then I want a dash, and then I want a 2-digit month, which is %M, lowercase m, and then %D for the 2-digit day. Then there's going to be a capital T, and then I'm going to have a 2-digit hours, probably 24 hours format, %M, and then a colon, and %S. And see, that's now converted it into a date time object, which is the 27th of August 2020. So that's all good. And I want to do that for all events. Okay. So, well, I could just create a loop around that, but you can see how we've done that. I've done that in the solution here. So I've done a loop for event in events. To assign that new time and date that I've created, I just say event, which is a dictionary. There's the key, time start. I use the assignment operator equals and the parsed value. So I'll run through that loop to do all those calculations, and then I'll print, because there's 200 of them, so then I'll just print out from 20 to 41. There we go, so start, this is my new date time, and that came from this string here. Which had a time zone in it. I didn't remember getting the time zone. Let's have a look at the time zone. No, so there's no time zone in the one that I checked, but if you look at, let's look at 21. Oh no, the time zone's just been put on automatically. Oh yeah, there we go. There's another field called start time zone offset that I didn't notice. And so what I've had to do is I've had to construct the string by using the start date time and the start time zone offset, and then I could parse out the time zone there, %Z, which is time zone, for example, minus 0500. So I've had to make a string and then parse that string to include those time zones. Why is live before library events? Okay, very good question. So when Python sorts alphabetically, it's based on the Unicode values of these characters, and in these ones it's the same as the ASCII characters, the ASCII values. And all the uppercase characters come before all the lowercase characters. So uppercase V is actually sorts ahead of lowercase b. So if you want to change, if you want to sort alphabetically, you'd have to convert it to all to lowercase or all to uppercase, and then do a sort on that, and then convert it back to how it was. So maybe keep a record of which ones. Yeah, that's going to be complicated. Is pprint source code available for review? It sure is. So I'm going to look at that. So in here I'm going to add another cell above. So I did Command M A, and that inserted a cell here. And then I'm going to import inspect. Okay, and run that, and then I'll create a new cell above that, and we want to do inspect get source of pprint.pprint, and that's the source code for pprint. It's a bit hard to read there, so what I'm going to do, I'm going to print it. And there it is, pprint, pretty printer Python object, and there's really only two lines in it. Printer equals pretty printer, printer.pprint object. So you could then look at the source code for any of those functions and classes. So you'd have to look up the source code for pretty printer, and then you'd have to look up what pprint does in pretty printer. But you can see that if you'll get there eventually to see all the source code for how that works. Okay, so the next question was, what's the difference between set and set for defining an empty set? And the thing is, one creates, because we use the curly brackets for dictionaries as well as sets, they've decided that an empty set of curly braces is going to create a dictionary, not a set. So that was just an arbitrary decision, and it's because dictionaries are more commonly used than sets. So the only way to create a set is using set like that, or if you've already got a set populated, you can use curly braces, but it can tell by the data that's in it that it's a set and not a dictionary. Okay, I can think of another use of it to extract info. What is the function of f in the print? Yes. So I've been using these format strings, and I put an f here. It doesn't actually need to be there. I was just by habit. But the f here does need to be here. And what that's created is a format string, which means that anywhere I want to print out the value of an expression, I can just put these curly braces inside the string, and then I put an expression in it, and it'll evaluate that and include it into the string. And it's just such a popular feature. It was added in Python 3.6 that it was so popular once it got added that people have been using format strings just everywhere. And you'll see a lot of libraries now require Python 3.6, and that's because they've used format strings as part of their code, and so they can't use any Python earlier than 3.6. So let's do a couple of examples of format strings. So if I have a string, my format string, and then I do curly braces, you see it's a different color, so Google Colab knows that there's something special about that because I've got an F out the front. If I didn't have the F out there, it's all be red. It would just display like that. And if I had 3 plus 4 in there, it would just display 3 plus 4. But because I call it a format string, it evaluates what's in there and then prints the result, which is 7. And you know, you can do other things with that. You can put a colon in there, and then you can say how you want it. You want it right justified, 5 characters wide. You want it to be 2 decimal places and a floating point. And so it's given me 3 plus 4 equals 7.00. So very powerful format strings, and you just define the format string by just putting an F out the front. Okay, so we'll move on. Find the first with Planetarium category calendar Planetarium, and print the location, title, and start date. So I could do that. Let's say I'll use a loop. We'll start with I equals 0. We'll just have the category equals events I category calendar, while I is less than the length of events, and category does not equal Planetarium. We just want the word Planetarium inside category. I plus equals 1, and that bit of code again. And what do we want? Oh yeah, print events I location and start date time. Okay, so that's started a loop. We're just checking that our I is in the bounds of that list of events. So we just check it's less than length of events. And we're looking for, if Planetarium is not in category, then we increase I and just keep looping until we get to where it is equal to, or Planetarium's included. And so we should actually print out what the category is. And the calendar, it's Brisbane's calendar Planetarium. So that's one way of doing it. Here we've got a solution here which has used a for loop rather than a while loop. The advantage of the for loop is that we only have to look at category calendar once rather than have to in 2 places before the first time through the loop and during the loop. And then we print out the results. And then I use the break command here, and what break does, which is inside this if, is it breaks out of the enclosing for or while loop. And so it doesn't go any further. So that also finds the first one, and it gives us the same answer. I've done time start, which is when we converted to date time before, rather than the string, which was start date time. Okay, repeat challenge 4, but this time also print cost. So now we have to look at the structure of our structure. So let's see, I'll bring this one across. So where's the cost in all of this? Cost is here. So you can see what they've done. They've got a few fields here, like location, all day, start time, zone, offset. So they're all fields, keys with a value. But then there were some extra fields that they didn't define originally, so they called them custom fields. And custom fields then includes a list, and the list has got a field ID, a label, a value, and a type. And one of those labels is going to be cost, and its value is going to be what the cost is. So we want to do challenge 4. We've got to loop through these, find the first one with the planetarium, but then to find the cost, we have to loop through all the custom fields and find the one where the field label equals cost, and then look at what the field value is and store that in the cost variable. So I think for this one, we'll just use the solution that I provided, because I'm not going to do anything much differently if I typed it all out again. And there it is, it's got the cost out there. So it's adult, $10, child. So this is just one long string. And that's how we did it. So is that clear? Just ask a question if it's not clear. But I think that's fairly standard, just in a way of navigating through the dictionary of data that we've got from our JSON objects. All right, challenge 6. We're going to repeat challenge 4, but this time we're going to use regular expressions to search on Planetarium. Now, regular expressions are a way of searching on text, and they're really what made the Perl language. It's a very powerful language, and they've been brought across to Python. So it's they're fairly tricky to understand, and so people have set up websites even so that you can so you can practice doing your regular expressions. So we've got the documentation here. That's the Python documentation for regular expressions. So you can read through that, but we're just going to go straight over to regex101.com and have a look at that. So what are we looking for? We're looking for the category calendar has got the word planetarium in it. So I'll just copy that text and we'll go and have a look at regular expression 101. So there's the text that we're going to look for, and we want to find a match in here. And just tick on it here on the left in Python, because there are very slight differences between what you have to do in the different languages. And there's a few little clues here on things that you can type, but at the moment we're just looking for Planetarium. So all we have to do is, if we type the word Planetarium here as our regular expression, it will match Planetarium in calendar. And because we're not doing anything special, that's all we need to do. So regular expressions can be quite simple. So let's do that. Challenge 4. So I'll copy challenge 4. So we want to use re.search. So it's regular expression search on, and the first thing we want is the pattern, which is Planetarium. And the next thing we want is what we're searching. and that worked. So that's very simple use of regular expressions. We didn't really get much more than just using in like we did in challenge 4. And if I look at the solution down here, it's the same. That's exactly what we did. So nothing really special about using regular expressions. However, regular expressions do have some extra features. So let's have a look at a few examples. So say, for example, I want to search for the word recognise. There's two different ways of spelling recognise. We could spell it with an S or with a Z. So in regular expressions, I can just put square brackets around there, and that will give me the group of all, or the set of different values that it could have. It can have either an S or a Z and all those other characters, and that's what it will find. Sometimes I want to search on any word that's got a CA and then an E, and that third letter can be any letter that I like. So I can use the dot for that, and that's the special character for a dot, so that will match on came, cake, case, cane. Here's another example. Colour could be spelt two different ways, C-O-L-O-R and C-O-L-O-U-R. So I can put in the character for a question mark, and that says it means 0 or 1 instances of the previous character. So I got 0 or 1 use, and that will match. Meanwhile, an asterisk means 0 or more. So I can have lots of any characters as long as it starts with CA and ends in E. In fact, it doesn't even need to start with CA at the beginning of the sentence. It could just be anywhere in the sentence. If I do want to lock it to the start of the line, I use the circumflex, and if I want to lock it to the end of the line, I use dollars. So regular expressions are a bit hard to get your head around, and I'm definitely not an expert myself, but we'll practice a few simple ones, and then we'll look at some of the more advanced ones that are possible. And really, even for those ones, I wouldn't be able to work them out myself. I just start searching on the net for how other people have created a regular expression that does what I want. And if you get the regular expression right, then you can save yourself writing lots and lots of code for trying to take into account all the different options that you could be looking for. So Leo asks, so the dot signifies and? No, the dot signifies any character. So a dot in a regular expression is any character. So it could be an M, a K, an S, or an N, or any other character that's there. So the dot asterisk means any set of characters, but the asterisk could be 0 or more, so there might not be any characters. It could be just CAE, or it could be CABLE, cable. But the best thing to do is to go off to here and type in your regular expression. So if I put a dot there, it still matches. If I put 2 dots, it doesn't match. So 2 dots is meaning I've got 2 characters that are blank. So if I take out the A, now it does match. Then I want any word that starts with PLANE. Then it's got 2 characters that could be anything, and then ends in RIUM. So that matches. If I don't know how many characters there are going to be there, I can put an asterisk, and that'll match, and that'll even match. So let's put another word in here, Planetarium. I'll just all right, I'll put that on another line. So we can see here that that matches because it starts with plain and ends in rium, but can be anything in between. So like I could just keep typing and typing and typing, and it still matches because I've got an asterisk up there. But it still matches Planetarium, so I've got two matches here. And you can see the blue and the light blue and the dark blue. And it tells you over here the light blue is matching that, the dark blue is matching that. And it even does a breakdown of what I've said here. It says Planetarium with a dot and a star. The dot star matches any character except for line terminators. The star quantifier matches between 0 and unlimited times, as many times as possible, giving back as needed. And that's called a greedy match because it gets as many characters that still satisfies the match. Okay, so let's have a go at some of these. We want Planetarium with an uppercase P or Planetarium with a lowercase p. So we want to match Planetarium, but the P can be uppercase or lowercase. So we've got both of those, and so I just put square brackets around those, and that hopefully that'll match. So that should, in this string, we should match there, and it should match Planetarium there without the S. Okay, match Planetarium only if it is at the end of the line. All right, so and the end of the line character is $sign. So I want nothing between the M and the $sign, but I still want to be able to have upper or lowercase p. And I want Planetarium with or without S's at the end. Okay, so same thing. So I want an S, but I want 0 or 1 S's. So the question mark means 0 or 1. So let's run those. So the first one worked. I got Planetarium or Planetarium, upper or lowercase p. The second one, I spelt Planetarium wrongly. So let's spell it properly. And this one I spelt Planetarium wrongly. So we'll do it again. The second one, it only matched the one that's at the end of the line, and that's what you'd expect because we only had one line. And the next one, we've got Planetarium or we've got Planetariums. So you see how S question mark, I get different matches here than without the S question mark, which this time just had the words Planetarium. So if you want the S included, then put the S question mark at the end. Here's the solutions, pretty much the same. The only difference was I used the flag re.ignoreCase in this case. So that to put flags in there, it means I don't have to do a uppercase or lowercase p. I can just put either and it will ignore the case. So if I run them, you can see that. And if you look back on Regex 101, it puts some flags, the Regex options here, so you can say multi-line, you can say case insensitive, extended, single line. So if I say extended, then it will also match Planetarium. So it's case insensitive. And if you want to use those flags, if you want to use more than one flag, so what flags have we got here? Multi-line, let's try multi-line. Not that we need it here, but if we want to do more than one flag here, you use bitwise OR operator, multi-line. So you can do more than one flag and use the bitwise OR, which is one of the few places you would use bitwise OR. Okay, so find all events which are not free. So we need to loop through all the events, and then we're going to check, find the cost field in custom fields, which is where the label equals cost, and then we're going to search on the value. So I could do this, that's right, for event in events, and a colon for the end of the start of the loop, for field in events custom fields, if field label equals cost, and re.search and not re.search. So search looks anywhere in the string of the value string. I've got the pattern, so we'll stick the pattern in there. And then we just print the results, so I'll just copy that from here. For field in event, break. Where are we up to? Okay. So in this one, I've done the search as we did before, re.search. There's the pattern we were looking for, so we're making sure there's free is not in it. If field label equals cost and not free in the value, then print that and print field value. So category calendar, field value. So I'm getting some free ones here, which I wasn't expecting. Oh, okay, and I'm getting free ones because I want upper or lowercase f. There we go, so $5, $5, yep, so I haven't got any free ones. So that's the way we've been doing it. We've been putting the pattern in here and doing a search to see if we've got a match. So that's one way of solving that problem. However, if we do this, we can, if we're doing a regular expression that we're going to use quite a lot, we can compile it, and then that just means it'll run a little bit faster. So it gets compiled once rather than every time, and then we can use it. So here where we had re.search, now we use the pattern that we've compiled and free.search in field value. We don't have to put free in here. And you can see here we're searching on free and we're ignoring case. So that's another way of running the regular expressions. It's slightly higher performance if you're having to do it many times. And so if I run that, we should get the same answers. Yep, that all looks the same. Okay, now other things you can do with these regular expressions, you can start to extract data from the cost record, from records, and so we'll use find all. So that'll find all parts of a cost record that match particular data. So we want to extract all the numbers. Now to do numbers, so let's grab a cost record. Here's one here. Well, let's just see what's in cost. Yeah, we've got one already in cost. So we want to do a find all. cost, and the pattern is we're going to look for numbers. So to find numbers, we could do there's a couple of ways of doing it. We can do digits, and so that's finding all the digits, 1, 0, 0. I might print out cost beforehand as well so we can see what we're looking at. 1, 0, 0, 0, 0, 3, 1, 4, 6, 0, 0. Okay, we can have a whole bunch of digits that are together, so we want one or more of them. So that gave us 10, 0, 0, 3, 14, 6, or 0, 0. But because the dot was there, that split the number between 10 and 0. So we want to include dots because they're decimal points. So we want this to could be either a digit or a dot. Now if I can do slash dot. And one thing I should be doing when I'm using regular expressions is using raw strings. And so I put an R out the front, and that just says a backslash is a backslash. Pass the backslash all the way through to the regular expression. Don't look at it as escaping. So you know that in normal strings, if we did backslash n, we mean a new line. Backslash t means a tab. Now, up until now, I haven't accidentally used one of the ones that backslash means something, so it hasn't caused a problem. But if I did, it would cause a problem. So if I use a raw string, then backslash means backslash, and I don't. It'll get passed through the regular expression straight away, as straight as it is. Okay, so backslash d backslash dot. So that means dot. Use dot as a dot, not as any character, and now that split up the numbers as I want. And you'll even find, this surprised me, you don't actually need the backslash. If you're in square brackets, you don't need the backslash on the dot because you would never use any character inside brackets. So if you put a dot inside brackets, you definitely mean dot. And you can see that works as well. Okay, extract all the numbers using, and that is what we've done. Okay, so what have we done here? So another way of doing the digits 0 to 9, you could do 0-9, and that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or the dot, and once again we don't need the slash, and that gave us the same answer. Okay, so these are getting harder and harder. So when I first set up these exercises, they had more complicated pricing on their planetariums. Now they've gone and used the same pricing everywhere. So it's nowhere near as interesting. But here is one of the ones that they used to use. So how would we get the prices from that, but not get the other numbers out? So we don't want to have the 2, for example. Cost is not defined. Yeah, cost will be defined if you've run the previous code up higher, but if it's not defined, then just put a value into it. So that was the value we were working with. Well, that's similar to the value we were working with, so just use that. And that works. This one cost is we've defined it in the code, so that one will work. Okay, here's another code. This is the one. So let's have a look. And this one is getting tricky. So I think we'll take this over to Regex 101 and see if we can work it out over there. So this is our code. Here, we want to look for digits, so that could be just digits, so /D. There could be one or more of them, so we'll use a plus. And you can see how it's split it up already for us, 15, 0, 0, 2, 29, 0, 0. Now then we could have a dot, and then we could have some more digits. Now the number of digits that we can have could be 0 or 2, and so we can't use our normal quantifiers, which were like plus or question mark or asterisk, but we can use curly braces and say we want 0 to 2 digits. Okay, and we want it to start with a $sign, but $sign generally means end of line, so we have to escape the $sign. And we should escape the plus, the dot. But the dot is optional because we still want to catch up to this one here. So we want 0 or 1, which is question mark. There we go. And so now we've got the 3 prices and we haven't got the .2 adults. So we can copy our code from here back to our workbook. Find all. And we get, I didn't run this one, we're using cost as that. And we get $15, $29 and $5. Convert to float. Okay. So you can see we want to include the $sign in the search, but we don't want to include it in the value that we get back. So what we do is we put parentheses, not there, we put parentheses around the bit that we want to include, which is all of that. So it needs the $sign to do the match, but when it returns the matches, it doesn't return anything outside of the parentheses. And you can see how regular expressions get quite complicated. And then we just convert those to prices. So they're all strings that can get converted to floats. And we just print the prices. So there's nothing more in solution 10, so I'll just run that one. And there we go, 3 floats, 15, 29, 5. And the advantage of doing that is that we can now do arithmetic on those prices. So if we had final events which cost, well, I should say 11 and 20, between $11 and $20, we can now convert to floats and return the values that do that. So that's just using the same regular expression that we had, and we've compiled that up into a regular expression. Okay, so I'll just run this one. Okay, so these are the events. We've got a $15, a $20, 15, and a 12. And we break out once we found it, the custom fields, yeah, that's all right. Okay, oh, it must be right. And now we're getting up to some really tricky ones. This is one that they used to have as a pricing. So we can see we had 2 adults, 2 children, or 1 adult and 3 children was $45. So lots of numbers here, but we only wanted to get the prices out of it. So there's different ways that we can tackle this problem. So just use the way that you feel most comfortable with. I've put down a few solutions down here. So one is find all the commas that are not between parentheses. So we want this comma here, we want, and you can see all the commas, but we don't want to split on those commas. So let's have a look at that. I'll grab that string. So that's looking pretty good what we had before for getting out the prices, but what it doesn't do, we also want the description to go with the price. So here's, and you can try reading the how this one works. So we've got a set of characters. But it's got the circumflex in here, which means we want to start with characters that are not included in this set. So never start with a comma or a parentheses. So these can't be a start of characters because that would start with parentheses. Plus means between 1 and an unlimited number of characters. And then we start a capturing group, which is with the parentheses in green, but it's a special sort of group. It's called a non-capturing group because we started it with a question mark colon. So these are the more obscure members of regular expressions, but by putting it here, it tells you exactly what it is. So it's looking for, in this group, anything that's a parentheses or any character, any number of characters, followed by a closing parentheses. So this is all going to be included, but it's not going to be captured. And then it's going to be followed by, it's going to add that as many times as you want, and then followed by anything that's not a comma. And so when it gets to a comma, it will stop, and then characters after that. So you can take out individual characters to see what the effect is of doing that. So if I took out that asterisk, it means it's going to stop before it gets to the comma. And it explains here what is going on. So that's a pretty clever one. I wouldn't have come up with that one myself, but I did a bit of searching of how other people would attack this problem, and then I put what they'd done together to create that one. So that does everything we wanted, which was split it up, the price and description on the commas, and returns the find patterns. Now the other thing is, another way of doing it, solution 2, is to split on the commas themselves. So this one here, so I called this one a find pattern and this one a split pattern. So with the same data, I search for commas that are not included in parentheses. And this uses negative look ahead, so I'm not even going to try to explain how that works. But once again, that was quite successful in getting that, finding those commas. And then this one, solution 3, split on a price followed by a comma, because I noticed that every one of these had a price followed by a comma. So we can put in our pattern for a price, and then a comma, and then white space. And then I'm going to do a substitution, so I call this a substitute pattern. And I'm going to substitute back in the price, but without the comma. So to substitute back in the price, so I used my sub pattern, and I use a substitute. And now, normally you'd substitute in, you'd replace something with something. So you could replace commas, and I've just chosen a pattern that's I know I'm not going to find anywhere else, so I've used these Unicode characters because I knew there were no Unicode characters in the text, so I've just chosen scissors, paper, scissors. But then I put a \1 in there that says I wanted the first bit of the group that I caught, which was the number, the price, I want that still included. I don't want that left out. So the number goes back in, and it's just the comma gets replaced with these scissor, paper, scissors. And then I do a split. Everywhere I find scissor, paper, scissors, I split that and I get my pattern. So let's have a look what that results in. And I've got the wrong cost. So I've got to run this cell, and then I can run this one. So there's my original cost, and then it gets split out into the different bits of text. So regular expressions are quite tricky. I'm really showing this to you not so that you know how to do them, but that you know what can be done with them. A couple of the things that you should use when you're using regular expressions, you should use these raw strings by putting an R out in front of the quotation marks, so then you can just use slashes as they are, and that's a lot easier than in other languages like Java, where you can't do that, and you have to put in your regular expression, every time you want a single slash, you have to put a double slash, and then if you want double slashes, you've got to put 4 slashes, and it gets very, very complicated. Okay, so that's all for this week. I hope you enjoyed it. Let me know which bits that you found interesting or which bits you found tedious. So please leave some comments and maybe a like or something if you like the video. Next week we'll be going to an absolute beginners session. It's on Tuesday, so it will be we'll be looking at dictionaries and functions, but it'll be designed for absolute beginners, so even if someone hasn't done any of the other sessions, they should be able to come along and ask questions in that session, and I encourage people to do so. I hope you've enjoyed it, and I will talk to you next week. I'll still be listening on Slack, and the YouTube chat will cease as soon as I stop the video, but the Slack chat I can keep watching for a few minutes later. Thanks for all your thanks.